Welcome to Master Concepts in Chemistry. In this lesson, we'll discuss how to calculate the mass of a particular atom present in molecules of a compound. To start, let's read the problem. The question says, what is the mass of oxygen atoms present in 2.02 times 10 to the power 23 molecules of CO2? So basically, you've been given a certain amount of CO2 molecules, and they want you to figure out the mass of oxygen atoms present in this amount. So to solve such a problem, you have to recall the mole concept. So let's recall the mole concept. So the mole concept says that mass in grams is connected to 1 mole, and 1 mole is connected to molecules. Now, however, when you read a problem, we have been provided with molecules, so meaning we are over here. So they want us to calculate mass, so we have to travel in reverse. So from molecules to moles to mass. So how do we go from molecules to moles? To go from molecules to moles, we need Avogadro's number. So you have to recall that 1 mole of CO2 contains Avogadro's number, which is 6.02 times 10 to the power 23 molecules. And remember, for each relationship like this, we can always write two ratios. Okay. The first ratio, which we call the conversion factor, will be, I'll call that A, is equal to 1 mole of our CO2 over 6.02 times 10 to the power 23 molecules. So that is our first conversion factor based on our relationship that 1 mole of any substance contains Avogadro's number. And our second conversion factor, I call B, will be written as 6.02 times 10 to the power 23 molecules of CO2 over 1 mole of CO2. So as you've seen clearly, A is a flip of B. Okay, so once we understand that, then we can then pick the right conversion factor and then go from molecules of CO2 to moles. So if you look at these two, we want moles of CO2. So we have to pick the conversion factor with moles on top. So we'll pick this one here. So we'll say we need 1 mole of CO2 divided by 6.02 times 10 to the power 23 molecules of CO2 to go from molecules of CO2 to moles of CO2. So we have to multiply our value given here by this ratio to go from molecules of CO2 to moles of CO2. Okay, so once we have moles of CO2, we can't go directly from moles of CO2 to mass of oxygen. No, we have to convert the moles of CO2 to moles of oxygen. So to convert moles of CO2, so convert moles CO2 to moles of oxygen. So to convert moles of CO2 to moles of oxygen, we have to look at the relationship between our 1 mole of CO2 to our 2 moles of oxygen in our formula CO2. So 1 mole of CO2 contains 2 moles of oxygen. So once we understand that, then we'll be able to convert our moles of CO2 to moles of oxygen. So to do that, we have to include the ratio from the chemical formula. So that is our 2 moles of oxygen over our 1 mole of CO2, because 1 mole of CO2, the whole thing, contains 2 moles of oxygen. Okay. So once we've converted our moles of CO2 to moles of oxygen through this ratio, we now have moles of oxygen. And once we have moles of oxygen, we then go back to our mole concept relationship and bring in the molar mass of oxygen. And remember, molar mass of oxygen being grams per mole. So we multiply our moles of oxygen by the molar mass of oxygen in grams per mole, and then we get our mass in our mass of oxygen in grams. So you see that. So that is how you should play it in your mind before you start working. Okay, so let's now work the problem. So first of all, we've been given a certain amount of CO2, which is 2.02 times 10 to the power 23. So remember, we always write what is given top left corner. So these molecules of CO2. So we convert these molecules of CO2 to moles of CO2 using Avogadro's number. So moles of CO2 here, and then we have molecules of CO2 at the bottom. So CO2, so molecule of CO2 goes with the big number, which is Avogadro's number, and 1 goes with moles. So close it. So units on the diagonal cancel. So remember, the horizontal line means division and the vertical line means multiplication. So since we have molecules on top and molecules at the bottom, they cross out. Also, we have 10 to the power 23 on top and 10 to the power 23 at the bottom, so they also cancel out. So now we only have moles left, moles of CO2 left, which is what we want. So we now have to convert our moles of CO2 to moles of oxygen. And remember the formula again is CO2. So 1 mole of CO2 contains 2 moles of oxygen. So since we want moles of oxygen, we put 2 moles of oxygen on top and then 1 mole of CO2 at the bottom. So you see, 1 mole of CO2 cancels 1 mole of CO2. So we've now converted our moles of CO2 to moles of oxygen. Okay, so now that we have moles of oxygen, we now bring in our molar mass of oxygen since we want the mass of oxygen. So our molar mass of oxygen is 6.00 grams. Okay, so grams on top and moles at the bottom. Okay, so 16.00 goes with grams and then 1 goes with moles. So moles of oxygen, grams of oxygen, and moles of oxygen. Then we close our table. So moles of oxygen cancel moles of oxygen. So we just have grams of oxygen left, which is what we want. So if we multiply the top numbers together and divided by the bottom numbers, okay, keep in mind that we already cross out the 10 to the power 23. Then our answer should appear as 10.73 grams of oxygen. But again, we want to report our answer to the correct number of significant figures. So what we do is we look at the number with the least number of significant figures. So this number has 3 significant figures. This number has 3, and then this number has 4. Okay, so since 3 is the least number of significant figures, we have to put our answer to 3 significant figures. Remember, 1 mole and 2 moles are definitions, so they have infinite number of significant figures. So our answer to 3 significant figures is 10.7 grams of oxygen. Yeah. So thanks for watching.